hydrogen bound to sp hybrid carbon, like in the case of terminal alkyne, has a pKa value of 25, which is far more acidic than the hydrogen bound to the sp2 hybrid carbon or sp hybrid carbon. This little pKa table shows us that based on different hybridization of the carbon a hydrogen is bound to, the pKa value could change drastically. And the reason is the stability of the conjugated bases. For an alkane, the conjugated base has a lone pair occupying sp3 hybrid orbital. For the case of alkene, the lone pair occupies sp2 hybrid orbital, and for the case of alkyne, the lone pair occupies the sp hybrid orbital. The more S character, the more tightly the lone pair can be held by the nucleus, and the more stable the conjugated base. The more stable the conjugated base, the more acidic the conjugated acid. For the case of terminal alkyne, the hydrogen is so acidic, and it's actually far more acidic than the proton on the ammonia, in which hydrogen is actually bound to a more electronegative nitrogen atom. In fact, the conjugated base of the ammonia, this amide, is so much better a base that this ammonia could actually react with an alkyne through this reaction, generating an alkynide and an ammonia. Here, you react a stronger acid with a stronger base, generating a weaker acid and a weaker base. The generated alkynide can act as a nucleophile, react with a number of electrophiles, including alkyl halides, epoxides, aldehydes, and ketones, and so on. We're going to look at their reaction in our later discussion. At this point, I want to show you one example. If you have a primary halide, and ideally this primary halide is not hindered at all, under that circumstances, your alkynide nucleophile could attack on the partially positive charged carbon, removing a leaving group through a SN2 reaction mechanism, generating a new carbon-carbon bond over here. Show you one example. When reacting butane with sodium amide, in liquid ammonia, butanide is generated. Butanide could react with ethyl bromide through a SN2 reaction mechanism. A 3-hexene is generated. The new carbon-carbon bond that's formed is over here. This reaction has been carried out in the laboratory for 6 hours and generating 75% of the product.